Perfect. All right, so I am happy to bring this lesson up. It's almost the same exact process that we did all last week. The only difference is we're going to talk about it in a different wording. We're going to talk about it as the set of all solutions. Now, we aren't going to get all of the solutions, right? We aren't going to get every single solution, but this would be considered a set of solutions. We put in some x values for this. We get a y value. We put in an x value here, we get a y value. Okay? Set of solutions is just the solutions that work with that equation. Okay? So there's nothing really new. You guys have already found sets of solutions. You guys remember doing tables like this all last week? Those are the sets of solutions for the equation that you were given. Okay? Now, all solutions that are true within the equation. Let's see if these are true. Okay, what does that mean exactly? Put in a 0 for x. Put in a 1 for y into this equation. We got 1 is equal to 0 plus 1. Does 1 equal 1?
Yes.
Yes, that's true. Good. Let's put in 2 here. So 3 for y, 2 for x. Does 3 equal 3?
Yes.
Yes, that's true. Okay? So all the solutions in the solution set have to work for this equation right here, and this is a line. Let's try one more. 4 for y and 3 for x. Huh. True. Okay? Let's try one that might not work. All right, how about 7 and negative 2? Let's see if that's a solution. So I'm going to have negative 2 for y is equal to 7 plus 1. Does negative 2 equal 8? No. False. So we know that this is not a solution. As not a solution that belongs in our solution set. Okay. Now you might say, well, what's different? It is literally like a change in our vocab. But here's like the next idea that I think will bring it together. A set of all solutions is like cars on a road. Like cars on a road. Okay. If we had bumper-to-bumper traffic, and this was like a mile of road, how many cars could fit in bumper-to-bumper traffic for a mile? A lot, right? Maybe 1,000 cars, maybe 500 cars. I don't know. You know, it's a bunch though, right? Okay. So each car has its own point. Each car has its own point. Each car is on the line, correct? If I had a car out here, it's one of those boxy Mercedes cars. Is that on the road? Is it on the road? Not on the road. So I know that if I found the point for this, let's say it's at 3, 3, 5. So it's like 3, 5, 5, 3. If I plug in 5, 3 into this, do you think it's going to work? Are we going to get a true or are we going to get a false?
False.
False. This is good. So y is 3. We'll plug it in. 2/3 times 5 plus 2. Let's see. We get 10/3 plus 2. We get about 3.3 plus 2. Is this going to work out? It's like 5.3 repeating is equal to 3. Is that true? No, that's false. Because the car at that exact point, where did I say? Like right here. At that point, the car is not on the road, right? So the car is not in our solution set. That's all there is to it. Somebody give me one of the points for one of these cars. Just kind of estimate it. Just kind of estimate it. Yeah, you got one.
Oh, I do? Okay.
Oh, yeah.
Like the one closest to the Y on like the Earth quadrant.
Nice.
That one?
Yeah.
Yeah, that one.
Boom.
It's 1. Oh, wait. It's 1, 3, yeah.
1, 3, approximately right there, right?
Yeah.
Perfect. So this car right here is at 1, 3. Everyone agree? All right, someone else give me another. What's another point up there that you could say, make an argument for this car is at this point? What do you think? What do you, Jackie?
The car that's like the bottom, not on top.
This
that
one.
one.
Okay, good.
It's 0, -2.
Perfect. 0, other way around.
Oh, -2 and 0.
Yeah, yeah. So we know that it's -2 for x. 0 for y, -2, 0. Right? It's perfect. Any other car points you can see that's kind of clear? Yeah, Joe.
The second one in the first quadrant is 4. It's 4.
4 for y.
4 for y and the x. 3.
Yeah. I think that angle right there with this estimated graph is a little tricky to see. 3, 4? Okay, what do you think is going to happen if I plug in any of the points, just for 3 of the cars, into this equation? What do you think is going to happen? We're going to end up with a true or a false? True, because if the car is on the road, it is a solution on that road. Okay. Now, how many cars or how many points would fit between this car and this car? How many points could we fit between those? Could I break it in half? Just think of like if you're looking at something, you zoom in, you zoom in, you zoom in. You get to a place eventually where there's space between everything. You're almost looking at like the microscopic view of it. So you could say, well, I have this point, these points right here, but go in closer, zoom in right here, and between these 2 points, there's like infinite many there. Zoom in, there's infinite many there, zoom in. So you can have infinite number of points on that road. But we just want to keep in mind that if the car is on the road, if the point's on the road, then it will work in a solution. Let's try one up here. So yeah, this one. Yes, no, that one. Let's do this one. 4 is equal to 2/3 times 3 plus 2. 4 is equal to 2 plus 2. 4 is equal to 4?
Yeah.
True. So I know that this point right here, I just plugged it in. I know that that's on my line. How are we doing with this? Thumbs up, sideways, down? It's just conceptual. You're like, wait, what do we do with it? What's the use? Okay. All right, so this is going away. I'm going to go ahead and draw this right here. I want you to go and put this, it's like x is equal to y. It just goes up at 45-degree angle, goes up halfway. All right, from the graph, I want you to name 4 points that are solutions. So tell your partner 1 point that is a solution after you graph that, and then see if they have one as well. All right, I hear him. I hear a bunch of good ones. Any of those. Good. All right, that's pretty good. Who? Raise your hand if you said 0, 0. Perfect. 0, 0. Who said 1, 1? Good. Who said -1, -1? Yeah. That's rare. Who said 3, 3? All right. We got enough points there. If it was a graph, on a nice graph. Oh, by the way, I ordered some graph paper. Don't refill your binder, but you can come get a piece of graph paper if you need it during the day. Okay. So there's some graph paper. I have some regular paper too. So just ask me for that if you need it. So we got our 4 points. We got -1, -1, 0, 0, 1, 1, 3, 3. Who got another point? Who got another point in there? Yeah.
-2, -2.
-2, -2.
I had 2,
2,
too.
2. Okay. Did anybody have 1.5, 1.5? Could you have done that?
Yes.
How about 1.976, 1.976? Right. So you see there's infinite number of solutions here. You could pick 1.000009, 1.00009, right? Because it's this equation is y is equal to x. So every 3, then 3, 0, then 0, 1, then 1. Okay. So just trying to point out there's an infinite number of cars kind of on this road. So far so good. That's going to be you're given a graph. You got to find where we have exact values. Okay. This is the last thing we have to do. Okay. Here's the equation for money earned at your yard sale. Graph and find the amount earned at 3 hours. So make a strategy. Tell your neighbor what you're going to do to figure out where is my money earnings at 3 hours. Yeah, if you're not sure, no worries. Okay, I'll see if you guys got this. Somebody tell me, what X value should I plug in?
1.
1. What else?
2.
What else?
3. 4.
-2.
I like that there's something out of order. Perfect. -1. What's next? 2. What's next? What is the most important X value right here?
3.
Why is it 3?
Because 3 hours.
3 hours we're trying to figure out how much we earned. So here's the deal. What if we forgot to put 3 in our list? Tell your neighbor, how are we going to find it if we didn't even put 3 as a number that we tabled out?
Oh yeah. I get you.
All right. Somebody for Starburst, tell me what they and their neighbor agreed on. It's a pink Starburst.
Oh my
It's
god.
the only one in there. That's not true. That'd be a jip. They gave you 1 pink. Yes.
So what you got in the first one, what the answer that you got in the first one, we're gonna add it to the second one. Answer.
I'm not sure. Maybe that's part of what we need to say. I think there's one other part I'm looking for though, and you may have described it. I just used different words. Okay. Anybody else have a idea? Yeah, Genevieve.
Maybe you can have like 2 different points that are like between 3, and then like try to round.
Try to round. Okay, I like this. So kind of infer something about 3 by what's going on around it. What's going on around 3? We can maybe figure it out. Is there any way graphically? This is still worth a Starburst. I'm looking for this, Jackie.
You can go by well, I mean, well, it's multiplied by 2.
What's multiplied by 2?
X.
X is multiplied by 2. So, but going by 2, I'm still a little confused with that. Think about that one. You can clarify.
You would input, like, for example, you would input 1 for, in the equation, and then that you would add 2 That's so, right?
Oh, I see. Well, the slope is true that you're going to be going up 2 and maybe over 1 every time. Now, that is good. You're on the right track. You're on the right track. Woo! Oh. Got to keep your eyes open in here, man. This thing's flying. All right, Caden, do you have something to add, or should I round all those ideas together? How about from the graph?
You gotta go up 10 first.
You know.
If you grab it, then you can just look at the 3 on the graph.
It's the car.
Boom!
Boom!
It's somewhere, man. It's somewhere. Okay. All right, let's do these quick. What's 2 times 1?
1, 2.
Multiply those 2 numbers together, you get 2 plus 10.
Oh, 20 to 12. 2.
What's 2 times 2? 4. 2. 4. Plus 10.
14.
What's 2 times negative 2?
28.
-2.
Negative.
Negative 4.
Hey, try it, man.
Negative 4.
Plus 10?
6.
You sure, or are you good listening? Little both. Little both. 112. Let's say this is 12. We'll go 112. We'll go 214. We'll go negative 2, 6. That's about right. All right, if this was a perfect graph, and it was like in the book, it had a grid, it had a perfect graph, tell us what to do. You got it. You got it.
Yeah, so you just look at the X.
Look at the x at 3. That's the time of 3.
And then where it meets on the line is where. Oh. Yes.
And it's hard. It's difficult to see with this. So maybe we just got to plug in 3 and see where that y value is. 16. 16? So 316 is what we're looking for. Woo! You see it? See it now? See, what I like about this is you can use the graph to figure out where the solution is. Tomorrow, all we're going to have to do is graph 2 lines, and where they intersect is the solution on both. Okay? So if you're on one line, if your car on one line, right? Your solution on that line. If 2 lines intersect, where's the one place the car could be to be on both? In the intersection between both of those streets. See what I mean? So the solution for 2 lines is going to be where they intersect, but here we're looking at specific times until tomorrow. Okay. Forget about tomorrow. If that was confusing, I'll teach you tomorrow. Thumbs up, sideways down for doing this all day long. Oh, I love questions.
So like, kind of lost on like the full like true and false thing.
Oh, what we were doing with this?
Yeah.
Okay.
I wasn't really paying attention.
Well, now's your chance. If you're paying attention now.
Yeah.
Okay, good. It's a solution if the numbers we worked out on the table, when we plug it in, end up having the x, the left side, and the right side working out. If the left and the right are equivalent, when we put in 2 values, we know that those 2 values are one of the solutions. So all of these were true, all of these were true, but then we got to, what was this? 7, -2. I plugged in -2 for y, 7 for x. Look what happens. -2 is equal to 7 plus 1. 8, is that true? No. It's pretty easy to see if it's not true, right?
Yeah.
So essentially, it would be the equivalent of having the car. It's true that the car is a point on the graph, but the car is not on the line. It's a solution if it's on the line. Okay. The equivalent of it being on the line is if it equates when we plug in those two components. All right. Is it good? Does that mean good? Okay.
No, that's me.
Oh man, not this again. Okay.
Yeah.
You're all. Yeah, that was good timing though. All right, what should we tell these people to do?
Subscribe.
They're being disrespectful. I need them to subscribe or else subscribe or you don't win a Kit Kat. On 3.
Isn't that implying that if they do subscribe and they get a Kit Kat?
Contrapositive.
If you're the 250th subscriber.
Yeah, that's a contrapositive is incorrect in there. You're right. There's cool logic ways to move around the if-then statements to know if it's true. Subscribe or else. Okay, subscribe or else on 3. 1, 2, 3.
Subscribe.